Let's talk about some other research that you've been doing with the quahog clam that might give us some insight here. What I have to ask you, what is it that makes a clam like a tree?
Well, that's first I probably should say why clams aren't like trees. I think everybody seems to know that, but we've talked a lot about clams today. But of course, clams are small, relatively small sea animals, as opposed to trees, which of course are very large land plants. But how they're like is that they both, as they grow, lay down a hard permanent material at their outer edges. Tree lays down an outer coating where you can see with the bark, and underneath that, and a shell lays down an additional material as it grows throughout the year. Now, so what we see is, so like trees, they lay down rings, which can be used as sort of a natural calendar, and that's how we know trees have rings. We can count the ages, and as I think, as one of the kids spoke earlier, you can actually use the rings, use that calendar to count the age of the shell. Here I've got two shells. One's a young one, not much older than some of the kids over here, or about the same age. This one's about 8 years old, and maybe is about 2 inches, 2.5 inches across, from the beginning area, what we call the hinge, to the outer edge, the growth edge. Here's a larger and much older shell, quahog. This one's approximate age is about 40 years. So it's old as some of the teachers out there, certainly, and maybe older than a few. Anyway, so you can count that, but that's something we know about. But what's really another really interesting thing about the calendar and clams is, as the clam grows, it lays down new material, and that material, new shell material, and that material is affected by the physical environmental conditions in the water, such as temperature, the saltiness of the water, or as Joe was mentioning earlier, as pollution comes into the bay, or various nitrogen and compounds, those are incorporated into the shell material. So what's really cool, if you add those things together, the fact that you've got a calendar here and you've got chemical signals in the shell that are retained by the shell, well, then you can put those together and you can basically reconstruct or look back into the past to understand how things have changed over the lifetime of the shell as it's laid down new material. So you have a calendar and you have a record, it creates a permanent record of environmental conditions in the water.
You know, one of the things I think that's fascinating when you look at these two quahogs that you have here and the ages, this small guy here, who you said is about, what was that? How was he?
8 years old.
8 years old. They grow pretty slowly. I mean, you'd think that was a lot younger, wouldn't you?
Yeah, well, like people and like a lot of things, they grow fast at first, and then they slow down. But unlike people who sort of get to a certain size and stop, shells, like trees, continue to add material and get a little bigger. It's just that the rate of growth is much smaller over time.
We have a question from Mrs. Davis's class in Falmouth. The question is, do quahogs live only on Cape Cod?
Oh no, quahogs, we have quite, this particular species of quahog lives quite extensively all the way down to Florida in the warmer climes, and on up towards the Maine coast on the eastern side of the, up north here.
Mrs. Davis's class also wants to know, can quahogs live in fresh water?
Well, they can't quite live in fresh water except for very short periods of time. Quahogs are pretty hardy critters, so they can handle, they're used to living in estuaries, which one of the definitions of estuaries is lots of change, lots of saltiness and temperature change. But usually what they call 20 parts per thousand, which is sort of brackish water. It's sort of salty, sort of not, but it's more salty than it is not. They can live about that, but they can't really handle fresh water, no.
Thank you, Chris. That was very fascinating. Thanks so much.
Yeah,